Now coming to practically doing the, let me just end the show and show you a example. Now let's say this is a data in which we have 9 students ABC, MNO and PQR, right? We have their marks that they have secured in physics and mathematics examination, right? We want to find out the similar students, whether R is similar to E or M. So can we categorize these students? Looking at the data, we can say yes, ABC are similar, MNO are similar, they are mediocre guys, these are low mark securing guys, and these must be the topper in the class, right? Most studious guys. So, but how can we judge it by a algorithm? Now let me plot these guys. See, looking at the plot itself, we can say these people are similar. And these people are second cluster and these people are third cluster. So you can see the distance among the cluster is higher than that within the cluster, right? So within cluster distance is less and inter-cluster distance is high. So this is a data which we can understand looking at it, but if the data is large, we can't do it this simply, right? So we need to understand our algorithm. So let's do it in SAS. Alright. So how do we do it in SAS? So let's do it. First we import the data. So we are making a data. So I am just cleaning the library first. Alright, I just made a data, check, well it's fine. Now what I need to do, I need to write a Proc cluster. See, Proc cluster is for hierarchical clustering. What I do, Proc cluster data equal to check, method equal to centroid. Well, this means that we are using centroid distance. We can also use complete average, we can use average, we can use word method and then run it, right? So for now I am using centroid. Anyways, now we are writing an option RMSTD. What is this? I'll tell you. Now I am writing a statement out tree. So it gives me result of this Proc cluster. Which variables I am using? I am using the attributes physics and maths, and ID is just to identify the output. Useful, right? So I am just running it. So it is giving me an output. What is the output? From here it has given me an output. So it has given me first the eigen of the covariance matrix, not useful in this regards for the cluster analysis. We should go ahead and see the cluster history. Well, what we do, we understand first. So number of clusters, how many clusters are there? So this is 1. So basically if you see, first we have made 8 clusters, then 7, then 6, then 5. So which sort of clustering is it? It's agglomerative approach, right? Now within 8 cluster, this is the RMS STD, that option we gave. This is the variance, this is the variance among groups. So variance among group, it's sort of theoretical here. So basically 9 and 8 observation So basically 8 clusters, there were 9 observations. So it must have made 2 observations together and rest 7 must have been different. So this variance, as you can see, is very low, right? The moment you start decreasing the number of cluster, the number is increasing, right? So I am extremely sorry, this is variance within cluster, right? So now as it is increasing, as we are making one cluster, definitely the variance would increase within cluster, right? Now what we do, we just take this data into Excel, right? I'm just taking this down and just deleting the rest of the information because I don't need it for now. Okay, I have got number of clusters, I have got RMS STD deviation, and then what I do, I plot it, fine, and I also assign the attributes to the graph. With this is the graph I have got. Now here I can see the within cluster variance is increasing with decreasing the number of clusters, right? Once there are 3 clusters, it has suddenly increased with a high rate, right? So at the elbow point, at this elbow point, we can say that it is optimum, right? It is optimum at this point. So ideally in this case we should make 3 clusters. So as we don't know how many clusters are we supposed to make, we use this technique to identify number of clusters, right? This is a dendogram that we have got. What do we understand by this dendogram? Student A, B, C, M, N, O and P, Q, R are there. First it has clubbed AB into one cluster, C is there. It has also clubbed MO as one cluster and RP as one cluster, and then it has clubbed RP and Q to make other cluster, right? It has clubbed MO and N as one cluster, AB and then C as one cluster. So if I take a cutoff here in the dendogram, there are 1, 2, 3 clusters that I have got, right? So with looking at the dendogram also we can take the cutoff, because after this you can see the distance is very high. So the moment we see sharp increase in the distance between cluster centroid, we can take a cutoff. This is the distance sharp, here it is very less, right? So we can take a cutoff looking at the dendogram too, but ideally if observations are more, you won't be able to decide looking at the dendogram itself. You need a numerical approach, which I told you, and one more that I will tell you. Alright, so alright, well, the graph that I just made is called scree plot. Alright, so finally on the output that we have got, we will finally make clusters. We will use Proc tree. We will give the A.tree data, that is the output of Proc cluster, as a feed to this Proc tree. We will say you should make 3 clusters and then give me output A.tree underscore 1, and I'll just give all the variables name here so that I identify clusters and run my Proc. So finally it makes a data tree 1 in which it has made a cluster variable in which it has said first cluster there are P, R, Q, second cluster A, B and C, third cluster M, O, N, right? So that's how it prepares 3 clusters. We can also plot this data to understand how it has worked. So you can see in the first cluster 3 people are there, in second cluster 3 people are there, third cluster, and also you can visualize that how far the clusters are and how homogeneous the clusters are within, right? So just to give you an understanding of Proc cluster. Fine. So one more example that we will understand for Proc cluster. We will make a data. This data I have sourced from I believe some open source websites such as UCLA. There are many websites. If you search on Google cluster analysis, you will find many examples. So I have quoted this example from one of the websites. I don't remember the name. So I make a data. Yes, 98. Just a second. Alright, so we made a data poverty. In the data we have 4 variables: name of country, birth rate, death rate, and infant death rate, right? So what we do, we first, so in the data earlier that we used, see the scale of physics and math was same. It was the marks that a student secured out of 100. So the scale of the variable is 100. However, if you are having this data in which there are 3 variables and you don't know what is the scale of 3 variables, right? So what we need to do for cluster analysis, we need to make it scale free. Fine. So if I go by PPT, first we should import the data, then we should standardize it. We can standardize it using Proc standard in which we give a data and we take out a standardized data. We should give mean equal to 0 and standard deviation equal to 1. This gives me a data, scale free data, and what variables I need to standardize, right? So we'll take this example later, and for now we will work with this example. So we have made this data. Now we just standardize this data. Alright, now one more thing that you should do is that you should check the correlation among variables. So let me check. Proc correlation that we should do, we should check the correlation among these 3 variables. We should check the correlation between, right, and where this, right, so we can see that infant death and birth are very highly correlated. Death and birth are not that correlated, right? So we should keep one of the variable, either infant death or birth, right? So let me choose infant death. Fine. Or sorry, I'll just remove infant death. I'll just take birth and death ratio of the data, and finally use Proc cluster on it. Here you can see I have used method var. I have put RMS STD that you are already aware of now. 2 additional options I have given are CCC and sudo. What they would do, I'll tell you. So I'll just run. So I'll just remove the old results so that it's easier to understand. I'll just close this and finally run a Proc cluster. It's taking time. Fine. it has given me a dendogram. So again the same eigen value of covariance matrix, not very useful for this analysis. Number of clusters, cluster history. Here we have got our RMS STDV, CCC criteria, pseudo F statistics and pseudo T R square. These are very helpful. I'll tell you how. What we do, we take this data in Excel again, right? What we retain is RMS STD, our squared T value, our pseudo F value and CCC criteria, and I just remove, right? I'll just keep the columns of my interest. Fine. Alright. Now earlier what we did, we have plotted this. Okay, let me plot it again. See, there is a very zigzag pattern. So can you identify the ideal number of clusters that we should make? No or yes? We can make this as cutoff, we can also make this as cutoff, but it's very difficult to understand the ideal number of clusters from this zigzag pattern, right? So we should have some other criteria to judge upon the number of clusters. Fine. So that's why we have used these options of CCC and pseudo. So all these three options help you understand how many clusters we should make, right? So I'll just come on this slide. We should make these three options to decide how many clusters we make. Method equal to average, we can take ward, centroid, complete, single for calculating the distance. Fine. Now let's say this is the output of the data that we have got. How to decide upon the number of clusters we should make? So looking at pseudo T statistics, what we should do, we should just forget the first observation and try to find the largest value of T, pseudo T, right? The largest value is 37.6, right? It is the largest observation, right? Now suppose that is kth observation, right? We should move to k plus 1 and that is the number of clusters. So 3 should be the number of clusters, right? So pseudo T statistics is also helpful to understanding the number of clusters that should be made. Pseudo F. Again we should just neglect the first one. Excuse me. Now we should see pseudo F start increasing upwards. It is increasing, but after a point it starts decreasing. So the moment it comes to local maximum, so this is local maximum 45.9, that point again tells you the ideal number of clusters. So what is this? 3. Fine. CCC has got a similar approach. You try to find out the local maxima. So just neglect the first one and see it is increasing here. It has increased and suddenly dipped. So this is the local maxima. 3. So all methods are telling you 3. So 3 is the maximum, is the number of clusters. So let's look at the example that we are right now working upon. So if I just freeze it, in T square value, I'll just remove the first one. The maximum is here, right? So we should move one ahead and make 3 as the cluster, right? In pseudo F, we should see that it starts increasing. So it started increasing from here to here, but it suddenly dipped. So 2 should be the ideal number of cluster. It started increasing till here and then it started decreasing. So 2 again should be number of cluster. Here CC and pseudo F are telling you 2 is the number of clusters that you should go ahead, and T square is telling 3 is number of cluster. So it's your call, but generally we take best of these 3 and decide on the cluster. So 2 is ideally the number of cluster. We can also make 3 as clusters. Let's see the result and then decide what should be the number of clusters. So here if I say 2 is the number of clusters and I remove the infant rate and make a final data. So basically what we are doing, we are keeping all these countries together and considering this cluster, and these all countries together considering this cluster. Fine, making a sense. Also if I take 3 as number of clusters, here what we are doing, we are taking this as one cluster, this as another cluster, and this as one cluster. So we can see in the tree that there is a cluster variable and which all countries have been assigned to which. We should not consider this, we should consider cluster as the a variable of interest. Fine. Let's see how is it looking in plot. So we can use as we have made more than 2 clusters, we can use Proc CANDISC to plot it. So I'll just remove infant there. So see, it gives you a plot in which all 3 third cluster countries are here, or second cluster countries are here, and all 1 are here. Looking okay, it's looking fine. How to use it? Proc CANDISC, data equal to whatever is the output of proc tree, out equal to something, any dataset name, variable that you have used, and class is cluster, that is the output of proc tree. Fine. And finally we can plot the canonical. So basically it gives you a canonical transformation of the clusters, and you can plot these values on clusters and find the plot. If there are only 2 clusters, you can have used proc plot that I have used earlier. Fine. So this is all about hierarchical clusters. So I'll just go back and see if I have missed anything. So this is one more example I have given. So this data you can find on the blog and you can work on it, and we have taken 100 observation as sample, right? We have taken 100 observation as sample and worked on it. You can try it at home. This is the output that you will get, and finally you make the clusters, right? So this is all about hierarchical clustering. Fine. In the next class you will learn non-hierarchical clustering or k-means clustering. And this is the Dendogram. Finally, we welcome your feedback and suggestion. There is always a scope of improvement, and we are also in learning phase. So please give us your feedback. Thank you guys.